So let's go over the reaction stoichiometry practice test. This first problem is a mole-mole problem, and so you are given 6.30 moles of fluorine, and you want to know how many moles of hydrogen are required. Notice it's a 1-to-1 mole ratio, so they're going to be equal numbers. So the answer is 6.30 moles of hydrogen. To get the second part of this question, you're going to take that 6.30 and take it times Avogadro's number, and that's going to give you the answer that you see there. And so that's how you get that one. And so the second question, this one goes to a mole-gram problem. So you're given 8.23 moles of iron, and you want to know how many moles of iron 3 oxide will be formed. So you start with the moles given, you use the mole ratio, then the molar mass. So mole ratio, then molar mass. You have 3 sigs working in the problem, so you have 3 sigs at the end. Of course, 8.23 moles is quite a few, so you're going to get a relatively large answer with the mass. Number 3. You've got a gram mole problem. And so you have, starting with 225 grams of sodium chloride, and you want to know how many moles of oxygen. So you're going to use, start with what's given. You're going to use molar mass, and then you're going to use mole ratio. And so those are the steps in order. And you end up with 3 sigs in your answer, 3.17 moles of oxygen. To answer the second part, you take those 3.17 moles, and guess what? Times Avogadro's number to get it to molecules. And that gives you the 1.91 times 10 to the 24th molecules. So that's how you get that one. Number 4, a gram-gram problem. So you're given 42.8 grams of water, and you want to know how many grams of potassium hydroxide are produced. And so you start off with what's given in the problem, the 42.8 grams. You use the molar mass of water. You use the mole ratio of what you are given to what you are finding. And then you use the molar mass of what you are finding. And so again, 3 working sigs. I'm hooked on 3. I don't know what my deal is, but I always do 3. It seems like. Every once in a while I switch it up and throw you guys for a curveball. But it's 133 grams of potassium hydroxide. Number 5. You're given 9 kilograms. We don't know how to do a kilogram-gram problem, so we got to change those kilograms to grams. So that's the very first thing I did in my head. Okay, kilo means 1,000, so 9 kilograms is 9,000 grams. And then I'm going to use the molar mass of given, the molar ratio, and then the molar mass of what I'm trying to find. And 3 sigs, because the 9 was 9.00. And so 6290 grams of iron. I have 700 grams of carbon also given to me. And so I have 12 grams of carbon's the molar mass. I use the mole ratio of carbon to iron, and then I use the molar mass of the iron. And I get 4,340 grams, which is the lower number. Therefore, that is the one I circled, and that is the correct one. And then number 6 is a percent yield problem. So you are given 4.56 grams of iron, and you're told that 4.45 is actually produced in the lab. So this makes this an actual yield. So that's where you see that used down here a little later on. So that's why we start with the 4.56 grams of iron. A percent yield problem is usually about a product, and that's why it's a percent yield, because it yields how much and the way you perform the experiment. And so we're going to start with the 4.56 grams of iron. and use the molar mass of iron, change iron over to copper using the mole ratio, and then the molar mass of copper. And I get that the theoretical yield's 5.19, so I divide the two and get 85.7% yield. And here is iron 3 oxide is the question that is about. And here's iron 3 oxide formula given to you up here. And I've been doing that all along. I've been giving you a percent comp problem of a formula that I've already given you. And some of you are still using the wrong formula. So be sure that you're not doing that. And so you only have two elements here. So you're going to have two answers. You have two irons at 55.8 apiece, three oxygens at 16 apiece. And so you get 159.6 as the total mass. Iron contributed 111.6 grams of that. I have 4 sigs here, 4 here. That's why I reported 4 in my answer. And then oxygen, I have 3 sigs and 4 sigs. And so I have 3 sigs in my answer. And so that's what the test is going to look like. I hope this was helpful. What I want you to do for the response part of this is I want you to let me know any questions you have. You can either email me the questions or you can ask them here and I will respond to you. Either way, I want you to be ready for that test on Thursday.